Welcome to the 7th video of our 14-part series on CAD design. This video will probably be the most important of the entire series, so watch it thoroughly. I'll try to make it short, compact, but as dense as possible with all of the juicy information that you absolutely need to know. So let's start back from the previous video. This is what we're trying to achieve, and this is where we're at. We are now going to organize our parts and our file hierarchy to optimize for assemblies. We're going to split the different parts of the wheel into either components or bodies, or as a completely new design that will then be imported into the assembly. Because of course, if I import first wheel into assembly, it's going to import first wheel plus component 1 plus component 2. These are all going to be imported when I import this first wheel by clicking right click, insert, into my new design. The logical thing to do, normally, is to think about where the joints are going to be in your design. A joint is a physical movement you can impose on bodies in Fusion. Movement or rigidity, a place in space. In file 1, which is, let's say, dynamic, we're going to have the wheel, so black. We're going to have the purple ring, so purple. You can do it. We're also going to have the tire, that's already black, part of the wheel. We also want to have the bearings, so blue. Great. The rest will be in the other file. So in the other file, we will have the motor arbor. So this arbor, red part, will have the motor itself. We'll also have this orange preload ring, and that's about everything we have. So this is our two files. Let's create them. What we'll do is create two folders called subassembly dynamic and subassembly static. This lets us understand where our subassemblies will be, and we will move our subassemblies to subassembly dynamic for the part that's dynamic, and we will move our subassembly static for the part that is static. Now, we will create a parts folder in each single one of these, and these parts will be the parts that belong to the subassembly. This will make it much clearer when you look for parts than having one big parts folder with everything in the same parts folder. So we said the bearings go to the move. We said the bearings were going to go to the dynamic part. So move them to parts from the dynamic subassembly. So I move the bearings to subassembly dynamic because, as we said, the bearings will be blue. So in this file, so in the subassembly that's dynamic, so the wheel, we move them to the parts of this subassembly. And now we'll move the parts that will be static, so the motor and the motor shaft, to the subassembly static. Alright, so we now have two files in our CAD class project file called subassembly dynamic with the subassembly right here, and subassembly static with the subassembly right here, and all the parts that will go into it. And we will now create our main assembly called, we can call this, so let's create a new design, and let's save it and call it main wheel assembly. So in this main wheel assembly, we will assemble all the parts of subassembly dynamic and subassembly static. We will now assemble the main assembly by importing both subassemblies. So how do you import a part or an assembly into a design? We'll first look at the dynamic assembly by inserting the bearings. So I need to put two ball bearings here and here. Luckily, I've already made components for the wheel hub and for the tire. So let's now insert the bearings. I will click on parts while being in the assembly folder, and I will first insert the front bearing. To do this, you need to right click on it and click insert into current design. This has now inserted this file into this design. Okay, as soon as you do it, you can see that in the hierarchy, a new component, so a multi-part component now appears that has this link icon. This link icon means that as soon as I change the bearing file, when I open the bearing file, which is actually here, it will then update this file. So the bearing's in the middle of nowhere. I can now move my bearing to the right place. So you might be tempted to use the move option, press M or this move option, and just, let's say, turn it 90 degrees into space. And let's say, okay, this is good, maybe translate it. Now it's in my part, okay, as planned. Looks nice, great. No, that's very wrong. Don't do this. This is not actually inserted because it's just been moved in space at the right place. It's not actually, you haven't told Fusion where it should be. So if I now move my wheel hub, because let's say that I've got a big assembly and I need to move it further back, well, if I move it out, the bearing stays there. It doesn't come with it. That's because we didn't add a joint. When you want to insert any components or assemble components in your design, you need to add joints. Since we've split our wheel hub and our tire in the previous video into two components, we can actually have the same issue if we move just the wheel hub. If I now move just the wheel hub, you can see that the tire doesn't come with it. That's because we created components, and now we need to tell Fusion how they're supposed to be assembled together. To do that, we use joints. So let me do Ctrl Z and go back to my bearing. Before I add joints between my tire and my wheel, I'll show you how to add joints between the bearing and the inner race. So first, I'll show you how to move something cleanly first. So we'll click on the bearing and press move. Let's move it out so we can kind of see what we're doing. First, we'll turn it 90 degrees so that it's facing our bearing seats. Press OK. Move again. Now, when you press on move, by the way, you can choose what you want to move. A body, a component, a face, a sketch object. Right now, I'm on bodies. So if I select this component, it doesn't select because it's not a body, it's a component. If I want to select my wheel, I need to go into the component called wheel hub, then into bodies, and I can now select this body because it's looking for a body, but I want to move the bearing. So let's leave bodies and go to components. Now I can select my wheel and move, my bearing and move my whole bearing. So you can see that I can move it either from here or from different places in space. You should really set the origin of your move option to the center of a circle. Here you can see it's automatically clipping to the center of the bearing. That's very important. So here we want to move it cleanly to this race. To do this, you can either use move type, that's this current move type, that's free move, you can go in every linear direction, or you can turn it in space. You can also use the translate option, which just translates, or rotate, which just rotates. But if you use these different ones, and you've got a weird shaped components, you might have to reset the origin. So typically, if it didn't set my origin at the center of my circle, but it set it, let's say, maybe like this at a weird angle, or up there, let's say on a bearing, on a ball. I don't know, can I get it to clip like this? This would be very impractical, because if I now want to spin my bearing, I'm spinning it around a weird plane. And I'm actually just selecting a ball here, not the whole component. So what you can do is you can reset your origin. So when you choose set pivots, right here, this option, you can choose a point in space, which is just where your origin of the move option will turn around. So if you want to select the center of a part, you actually press Control. If you press Control, you'll clip into centers. Right now, I have Control put down. If you press Control and press on objects like this, it's automatically putting me in the center. If I just let it float, you can see my arrows have gone from dark when I press Control to light. Now it kind of wants to go wherever it can go. It's not going to go in the center. But if you want to have different centers, like if I want to have my move at the center of the wheel, I press Control. as soon as you put it down, you need to press OK. If your part is non-circular, you can first, before pressing OK, change the angle. Let's say it's actually a weird part at 60 degrees. I can press OK now. And so my origin is now at 60 degrees. This means that if I spin my part, I am now not taking into reference the XYZ plane of my drawing. I change the pivot angle or distance by this option, set pivot. As soon as you press V, now when you move the arrows, you actually move the entire part. But I wanted to show you this option in detail to show you this specific one. This is the most powerful one that you'll use all the time, point to point. When you're a beginner, you're always doing this. Taking free move, moving it around, somewhere around there, zooming in. You should never zoom in. If you have to zoom in to any CAD software, you're doing something wrong. It should snap automatically. Here, it doesn't snap, exactly. But you could move it in space with this option called point to point. So it's asking me for an origin point and for a target point. I want my bearing to be against this shoulder. So the origin point will be, I'll select this, any of these circles, will select the center point. You can see it in blue down here. I'm selecting the center point from any of these circles, but not this one. If I take this one, it's after the radius, and it will not be the end face of my bearing. I need to choose the end face. So let's say I choose this circle. So now my origin is this center of the circle. My target will be this or this. You can now see the blue line that's showing you where my part is going to go into my other part. If I press on this outer shoulder diameter, it's going to snap straight away at the perfect spot, just at the perfect depth against the shoulder of my wheel. That's what you want to use all the time, point to point. You can use it for circles, you can use it for faces, you can use it for corners. If you have a cube, you can choose the points at the corner of the cube and another corner. You should never free move in space. Okay, this actually has not fixed my issue. It's been moved, it's now at the perfect spot, but if I move my wheel, the bearing is still there. That's because I have not added a joint. I moved it properly, but that's still not adding a joint. So we'll do Ctrl-Z, Ctrl-Z, and we'll now add a joint. When you want to add a joint, you need to press the Assemble tab, or more specifically, the Joint tab. There are multiple types of joints. Most of the time, you'll be either adding rigid groups or functional moving joints. So you can actually find rigid joints in the joint type. When you click on joint and then on motion, you can see every type of motion you have. We'll look at these later. For now, let's click on position. So I am now in the joint tab and it's looking for two components. Of course, now you know very well you are comfortable with what a component is. Now you need to figure out which component you want to use and which component you want to join to. So here in our case, we'd like to join the bearing to the wheel. This works very similarly to the point-to-point option of the move option. So you need to select a point and another point and say what type of motion will be between these 2 points. These points are called joint origins in Fusion360. So you can either create a new joint origin straight from this menu, as you can see when I'm clicking on this, or you can manually go add a joint origin. You could do that. If you can't manage to clip it properly, you can add joint origins, and when you choose the point-to-point move, but the joint part of it, it's going to select these origins as the building blocks for your components. So typically, if I want to create a joint origin, I get this message. You will always get this message. You will get it when the component is in this position. So let me go on another tangent after the move tangent to the position tangent. This is very important. Let's actually go capture, cancel. So if I move my bearing, right, you can see right here, I've got this weird, let's move my bearing a bit. I've got this pretty weird blue-white part of my position tab. This position tab is showing you how your design is in space. You should have a base position to your design, which is where it should be most of the time. When you have moving components in your design, your base position will change because you'll, for example, have a bearing that spins, and now this race will be spun compared to this race. So this tab will pop up, showing you that you've moved your design. When you press this button, it's going to capture the current position and set it as the normal position for your design. So if I capture now, basically, that's how my design will always be. And if I move my bearing right here, press on move and move it again and press OK, it's going to tell me I'm not happy. You've now changed the design. Do you want to capture it as this will be the new base physical state of your design? Or would you like to revert to the previous state? If I click on revert, it now moves the bearing right back to where it used to be. So if I have a really big design with a bunch of components everywhere and I've moved all of them, I can move them freely and not be stressed out. Like move this, move my ball bearings out, move this, move this, move this, move this, move this, and be really like afraid because my design is completely destroyed. As soon as I press on revert, it all goes back. So you really want to use this option well and to not press this when you don't want to. If you press this and you save at the wrong moment, you could have a design that you will have to spend 2 weeks to fix because you might have a QA something. Typically, if you created a big robotic arm and you forgot that there was a QA that was floating around in space and you moved it a lot and saved it a lot of times and then you close the file, you can't go back. So you now need to remake the whole assembly and to put the keyway back where it used to be in the design. So you really want to use this carefully. It's a powerful option. So I'll revert, and I'll now finally show you how to add a joint origin as we said. So let's add a joint origin to this bearing. Once again, you do not want to be working in the main. This is the main file. You want to be working in the components. So let me work on, okay, you cannot work on imported components. That's a good point. So since I'm working on an importing components, if I want to change this, I should open it up. You can either go back to the Fusion file repertoire and open it up by double-clicking on the file. It's open right here. And for example, I could add a joint origin right into here. I could do assemble, joint origin, and I could add one here. So you can see I select this circle or this circle, and it's adding a joint origin in the center of my bearing. If I choose once again this circle, it will add it offset inside the bearing. You see between this and this, how it's offset? If I choose this by mistake, my bearing will be inside my part. So I want to use this geometry. So I'll press this one and press OK. You saw I could also have reoriented my joint origin before I actually put it down. If I now go to the subcomponent that this joint origin was built on, it's called outer ring because I clicked on the outer ring, I can see a new tab called joint origin. This is where it's at. I can right click it and once again edit it. And this lets me move it, turn it, flip it, translate it. If I want to have it further back, further forwards, I will use this origin to clip into my assembly file. So here, I don't want to change it. It's good. I can also flip it, whatever. It's good. But we had another issue. You saw that when I pulled away the bearing, every single ball left the bearing one by one. This makes the assembly very heavy and a pain in the ass to work with. So to avoid this, what you should do is create what's called a rigid group. A rigid group is like saying, okay, I would like a joint between the inner race and each single bearing, every single part of my bearing, to have a rigid joint. So I add a joint between this inner race and this ball bearing, saying that the ball bearing is at exactly this distance, and it will always be this way. To do this, you need to select all the parts in the ball bearing assembly. So click on the first one, shift all the way down to the last one. I've now selected all the parts, and I can do rigid group. Okay, this is like doing 37 individual joints and saving them at the current position. But watch out, if you've moved your design and you do rigid group, it will save this way. So you should make sure to do rigid group the first thing before changing any part of the design, so that you don't turn it into stone when it's in the wrong place. So, okay, perfect. Now I have a new joint tab in which is a rigid group. You can also see that in this assembly, since I imported this bearing from my computer, I don't have a history. That's because if I right click on the main component, on the subassembly, I can choose this option called Capture Design History. This is what we use usually. So I've just started capturing my history. Had I done it before creating this component, I would have seen this component, this rigid group, into my history. The reason why it's not there is because the file is much lighter for Fusion360 to handle if you do not have a huge history, because it has to recompute everything every time. It's much lighter for it to not have a history. So if you do not want to, if you want to have models that you can easily work with, and you do not absolutely need to have a history, because you just do small improvements on a design, like add a rigid group or add a joint origin, you shouldn't put one. So I'll turn it off. Continue. This will make it lighter. Great. So I've now got an inner rigid group and one single joint origin. You can see now, if I try to move it, I can't move it now. I need to move, I'm moving the whole part, not just one ball. That's because it's got a rigid group. So if I want to rearrange it, I need to remove the rigid group by clicking either delete or by clicking suppress. Suppress will remove it just for a moment to let me remove just one or two parts. And then I can press unsuppress and it goes back. So I will now save this bearing and I will go back to my subassembly. You can see that my subassembly is absolute chaos. But since we have now added a rigid group between every single part of my bearing and saved it, this imported design is now different. It's telling me the component is out of date. To update it, please press on this triangle. If I update this child component, it will automatically update my subassembly, and the update that I've done is create a rigid group. So it will be impossible for my parts to be floating in space because this part will not be free. It will be grouped from the rigid group that I just added. So once I press on this, it's going to regroup all my parts, all my floating ball bearings, into the right place in space, like shown on this design. I'll do it. Perfect. Not only has it been regrouped into one clean ball bearing, also I can see my joint origin. Perfect. So one downside is that my joint origin is on the wrong face of the bearing. So I could either use this joint origin against maybe this surface, since I know that it's exactly 10 millimeters, so the thickness of the bearing that I've got between this face and this face, as you can see down here, 10 millimeters. Or, which I like doing better, because if for any reason I want to make this deeper, I can flip this bearing around by pressing on move my bearing to get back to a vertical position. Perfect. Now I can flip it around on its side, and I can either add a new joint origin, which I'll do for now, onto this. So once again, I'll capture. I can add a new joint origin to this circle. Okay, no offsets, perfect. Now I have two joint origins. You can see it just got saved to wheel hub. I'll actually go to wheel hub to do all of these joints into. So I'm now selecting the wheel hub components for my joints. I can now add a new joint. Since I have two joint origins, I can now add a new joint and select both joint origins, this one and this one. You can see that since the joint origin of my bearing was put on the outer race, only the outer race snapped into place. It snapped properly into place because both my joint origins were on the same plane. If I had had offset, I would now need to move it sideways to compensate for my offsets. But it's perfect, so I won't move it. This is where I can align my joint. If it's upside down, I can also flip it along the plane. But I'm great. So you might ask, how do I fix these ball bearings that are now floating in space? Do I need to do joints for every single ball bearing against the inner race? Well, no. Since you've already created a rigid grouping of every single part in the 6816 file, like we've just done, as soon as I press OK, it's going to snap back in place because the rules that you've given to the design are, I want the outer race to be rigid to this wheel, and I want this entire bearing to be one single part. So I could set the motion type now. It could be rigid. It could also rotate around this thing. You don't see it, but this ring is actually rotating. I could also translate. This would create a joint that I can move with my mouse to move around the part. I can have a cylindrical one where I can move and turn, or a pin slot where I can translate and turn, or different planar or ball joints around this center point. Here you can see that Fusion is quite powerful. You can do some quite cool joints with Fusion. So in our case, we're just leaving a rigid group. So you could ask, and when you give the rigid group, it gives you this shaking animation to show that it's rigidly fixed. So I'll press OK, and you'll see the bearing snap back because it has to follow both rules. OK, boom. That's because the rule from bearing and the rule from the joint are now applying. And you can see in my main menu, a new joint tab has appeared, seeing this rigid joint. This diagram in space means that you've just added a rigid joint to the assembly. So let's now add the second bearing much faster. But before, let's go on a third tangent. You could say that, well, why don't you add a rotating joint between the inner race and the outer race? And you'd be right. If I wanted to represent the world perfectly, I would have to add a rotating joint between the inner race and the outer race. I would also need to add a rotating joint between the ball and both the outer and inner race, but it's not just rotating. The balls are rotating on themselves around this main center point. So it's a sort of like planetary joint that's moving like this. So we won't do this. Of course we won't do this. It would take forever and it's going to kill your Fusion because it has to compute all this whenever you want to move the model. So what we'll do instead is simply cheat and give a rotating joint between the arbor and the inner race. So in real life, the ball bearing is not for this. The ball bearing is to let the arbor be pressed into the race and let the race spin. But we do not model things in Fusion like the real world functions. We model them simplified for our Fusion assemblies to work better. So front bearing, good. Rear bearing, right click, insert into design. Perfect. This time I won't add joint origins. You can see it's bigger, great. Spin it, exactly 90 degrees. Translate it. Okay, great. Get into it. Joint between this circle and this inner race of my wheel. Perfect. Outer race, I can see it's clean, how I want it, great. So I didn't add a joint origin. I just clicked on the right parts of my design and it automatically added the joint origins and clipped it in. So we're good. Motion rigid, perfect. And I had already added the rigid grouping to this bearing. We're good, perfect. We now have both bearings into our wheel. Perfect. I can save the wheel. One last thing, you can see that I inserted this bearing while still working on the component called wheel hub. This means that this imported bearing is now under wheel hub. If I hide it wheel hub, I can't see this bearing. And this bearing is inside the main. So you can choose where you want to put both of the bearings. You can put them both inside wheel hub, or you can put them both inside the main. But they both need to be at the same place for it to make sense. In my case, this is a small assembly. I feel comfortable to leave the bearings in the main. So I'll click on it, drag it, and drop it on the main. Now it's jumped out of wheel hub and into the main. You should really avoid doing this. If I had done a big assembly, a big sketch, I would have deleted everything that I've just done, because it gives these horrible histories of, oh, he moved the component, cut and paste, moves whatever, and it makes it unlegible. So it would be much easier to just delete everything, delete the joint, go back to the main, and then now insert the design, and it would insert straight into the main hierarchy. But for this short assembly, and to show you what you should not do, you know, do as I say, not as I do kind of vibe, I'm showing you the way to not do it. So great, let's close this. Now, let's insert this into our main assembly, because it's nice to be working with assemblies on the way to see how parts are supposed to fit. And then when you change a subpart, you can now update the assembly and see how the assembly moves. So let's go up in the hierarchy and open the main wheel assembly. Now, I've opened this file. I want to insert this dynamic wheel subassembly into it. So I'll open the parts folder and right click, and as always, insert. This creates a new component, as we've seen with the bearing, but now the whole component is the dynamic wheel subassembly. So press OK. This is now in the center of our main wheel assembly. Great. Let's save it. Let's now go back to the subassembly static to build, to design our axle and to insert it into the main assembly. Alright, so I'm not creating a new joint between this keyway and this motor. I'll do it straight into the motor file. For this, I take a new joint, click on new joint, and now select, for example, let's say this half circle and this half circle. And now in theory, my keyway should be perfectly set into my part. Motion, rigid, okay, perfect. New keyway, inserted into design, new joint. Great. Once again, add a joint between this circle and this inner circle. This is going to butt up our motor against it. Great. And add a rigid type construction. Perfect. Okay. All right. It's now been added into it. You can see dynamic wheel, static hub. Okay. If you want to have this different color that you can see, you can come see how I do this in video number 8. So the next video, I'll show you how to do section views, colors and such, and inspect our wheel assembly to make sure that we did a good job. So we now need to add a joint between this subassembly, the static hub, and this subassembly, the dynamic wheel. So it's between these two assemblies that will have a rotation. The joint that will be rotating, the only non-static joint in our assembly today, will be between these two ones. It's why we decided to have this file hierarchy between two files, one being dynamic, one being static, between both files having a rotation joint, a rotating assembly, a revolve joint, and we would import both of them because it makes a lot of sense from the project management perspective to see only two subassemblies here and to have only one joint in this file, which is the main joint that the wheel will be using to turn, because the wheel turns, that's what it does. So once again, we want to add this part to our design. So static hub, move it out, as always. Create a new joint between this lip and this race, or this race of the bearing. Should be right against it. Perfect. Great. It should be just too small to not fit in here. That's exactly what I wanted. It's just too small. You can see this small gap here. That's designed by me on purpose. That's for the preload. I'll make another video sometime about printing parts and tolerancing parts for 3D printing or machining. For now, that's not the point of the exercise. It's just to understand how assemblies work. So my arbor is going to be assembled to the inner ring of this bearing, which is itself assembled to the wheel in the subassembly. So it should all be static and nothing should move. Great. Press OK. And oh, I broke it. Why did I break it? Because instead of bringing the arbor to the wheel hub, it brought the wheel hub to the arbor. And we forgot to add a joint between the tire and the wheel hub. So let's change this. I just changed it, so it's giving me a warning, out of date, update it, and it's going to snap right back to place like this. Perfect. Now we have a properly made assembly with everything being rigid. Good. By the way, as I'm talking about assemblies, just know that you don't have to go all the way back in the file hierarchy to find where you put your subassembly. If you've imported a subassembly into a file, you can open it straight away by right-clicking it and click on Open. This will automatically find in the repos where you've saved your file and will open it right like this. And so this opens my wheel subassembly. So here we are. We have now added the subassembly of the dynamic part of the design, so the rotating part of the wheel, and the static part of the design, so the hub that will not rotate, into the main wheel assembly. The last thing to do is to add the rotation joint between the hub and the wheel. But actually, you can see down here in the file history, we added this rotation joint when we first joined and inserted the dynamic and static parts together. This joint, though, is wrong. We added a rigid joint, and we said that the only joint in this main wheel assembly that's in the level of the main wheel assembly would be the joint that would be the rotating joint between the rigid and the rotating part. So let's edit the joint, and go from a rigid joint to a revolute joint. Now, the arbor is spinning inside the wheel, but you could also see it the other way around. Anyways, you have a rotational DOF, degree of freedom, between the arbor and the wheel. Press OK. Now, we have in theory finished all of our work. I should be able to show you that the wheel spins by simply rotating the wheel by pulling on it with my mouse. I'll first capture and save, and you can see that in theory, if I do this, well, that's weird. The whole body's moving. That's because we forgot the most important joint of them all, the ground. If we don't tell Fusion which part cannot move, it's totally allowed to let us move in space like this. Because, well, that's the main DOF. Like, there's still left, right, up, down, and rotation that we didn't say that the whole model couldn't do. For now, we've been modeling joints around parts. We have not yet said that the entire part in space was fixed. This is where ground comes in. Since this arbor will be held to the red arbor, to the rover leg, I will decide to ground this arbor, so the static part. Since this arbor is connected rigidly by joints to the motor, to this orange plate, that will not spin, I can actually ground the entire subassembly. I could ground this whole thing and it would be okay. But I can also ground just the arbor. I will now show you how to ground parts. I can ground the whole arbor by right-clicking on the subassembly and clicking on ground. Now, this will never move. If I try to click on this and pull it, it doesn't work. Why? Don't know. Let's go ground the arbor. Right click, ground the arbor, capture position. Now, the arbor, if I pull on it, shouldn't move. Okay, now it doesn't move. Why does this not work? I don't know. But this works. So now that I've grounded my arbor, I can actually probably take this off to make it a bit more clean, because it's doing nothing this ground. But now that I've grounded my arbor, it's not moving, and I can now spin my wheel. As you can see, my entire wheel is spinning around my arbor. And you can see right here, the joint slider that's rotating and showing you which angle the wheel is currently at. If I now capture my position at 84 degrees, my part will always be at 84 degrees. If I click on revert, it goes right back to vertical, which is what I want. So the caveat in the design is that, well, the motor arbor doesn't rotate, when in reality, the arbor of the motor here will of course rotate. That's the point of the motor. But if we do this, once again, it's complicated because you need to split the motor shaft between the motor body and have the keyway be rotating with this driving plate that's right here and hidden. So we make it simpler in CAD. The whole wheel rotates with the bearing and not the motor shaft. So it's false, but it's easier for Fusion and it works perfectly fine. And if you're going to do videos to sell to a sponsor how your design works, they will not see any difference. They won't notice it. So this is how we do to create a joint. You've now learned how to use the move option, the joint option, the assemble option, the position option, how to insert subassemblies into assemblies, how to insert external parts into assemblies, how to assemble them together with joints that function, how to set a ground, how to choose the angle of your revolute or translation joints. You should be pretty well informed on how to make good assemblies. Thank you for being with me for this 7th video, and I'll be happy to meet you for the 8th one, where we'll inspect our wheel, make an actual section view like this in Fusion, and explain to you how this whole color scheme works in Fusion. See you soon.